Question 12, Part A. The diagram shows a conical soap dispenser of radius 5 centimeters and height 20 centimeters. At any time t seconds, the top surface of the soap in the container is a circle of radius r centimeters and its height is h centimeters. The volume of the soap is given by V equals 1 over 3 times pi r squared h. Part 1. Explain why r equals h over 4. We can equate the ratios of corresponding sides of similar triangles. I've partially recreated the diagram here, and in particular, draw your attention to these two similar triangles. So I've drawn a line here which splits this isosceles triangle in half into two right-angled triangles. So look at the large right-angled triangle here, and then the smaller right-angled triangle here. And we can see that those two triangles are similar to each other. So the ratios of the corresponding sides are r over 5, so that's r over 5 is equal to h over 20. So that's h over 20. So these are the pairs of corresponding sides. Now we can rearrange this equation by multiplying 5 on both sides of the equation. So effectively taking this 5 here, moving it over to the other side, it becomes multiplication. We get r equals 5 times h over 20. Which simplifies to h over 4. Therefore, r equals h over 4 as required. Part 2. Show that dV/dh equals pi over 16 times h squared. The volume V is given by the formula V equals 1 over 3 times pi r squared h, where r is equal to h over 4 from part 1. So substituting h over 4 for r in the formula here, we get V is equal to 1 over 3 times pi times h over 4 in brackets squared times h. Now h over 4 in brackets squared expands to h squared over 16. So we can simplify that to V equals 1 over 48 times pi times h cubed. Differentiating V with respect to h, we get dV/dh equals 1 over 48 times pi times 3h squared. And that simplifies to 1 over 16 times pi times h squared. And that gives us dV/dh equals pi over 16 times h squared as required. The dispenser has a leak which causes soap to drip from the container. The area of the circle formed by the top surface of the soap is decreasing at a constant rate of 0.04 square centimeters per second. Part 3. Show that dH dt equals negative 0.32 over pi h. The area of the circle formed, A, is given by the formula A equals pi r squared, where r is equal to h over 4 from part 1. So substituting h over 4 for r in the formula, we get A equals pi times h squared over 16, or it can be written as A equals pi over 16 times h squared. We can set up a related rates of change equation using the chain rule. dA dt is equal to dA dH times dH dt. Now we know dA dt, it's negative 0.04, and dA dH is found by differentiating A with respect to h, and we get pi over 8 times h. So we get negative 0.04 equals pi over 8 times h times dH dt, and we want to make dH dt the subject. And we do that by dividing negative 0.04 by pi over 8 times h. So we can simplify the left-hand side here, and we get negative 0.32 over pi h. Therefore, dH dt is equal to negative 0.32 over pi h as required. Part 4. What is the rate of change of the volume of the soap with respect to time when h equals 10? Similar to our approach in part 3, we can set up a related rates of change equation using the chain rule. dV dt equals dV dH times dH dt. Now, dV/dH is pi over 16 times h squared, and we get that from part 2. And dH/dt is equal to negative 0.32 over pi h, which we got from part 3. So we're combining the results really of parts 1, 2 and 3 in order to be able to answer part 4. So our equation now is dV/dt equals pi over 16 times h squared times negative 0.32 over pi h, where h is equal to 10. So substituting 10 for h, we get dV/dt equals pi over 16 times 10 squared times negative 0.32 over 10 pi. And that evaluates to negative 1 over 5 or negative 0.2. Therefore, the rate of change of volume of soap when h equals 10 is negative 0.2 cubic centimeters per second, which we interpret as a decrease of 0.2 cubic centimeters per second.